Let's go. Okay, so in this question we need to find the increasing triplets sequence. If you have done the increasing longest subsequence, it's something like that, but this one is easy and can be done in a much better way. So what we need to find here is if there's an I, j, k such that I is less than j is less than k present here, and such that the value of nums of I is less than nums of j is less than nums of k. Okay, so let's take this example. See, 1 is lesser than 2 is lesser than 3, hence this is proof. Here 5 is lesser than here no such triplet exists. Here 1 is lesser than 4 is lesser than 6. You can even take 0 for this matter, but if 0 wasn't present here and 1 was present here, it would still work. And then let's go. Now there are many ways to do this solution. As you can say that if this question has to specify that can you do it in big O of n times and with constant space, so there are many ways to do it. The first is n cube way. I don't think that would be accepted, but let's just try putting like 3 for loops here, and I will be let's watch the constraint. Of course it won't be accepted, it's 10 to the power 5. Log n or n square would be accepted, maybe n square won't be accepted. So let's straight come to the the first approach was taking 3 loops and checking for each and every pair of elements. The next approach was using dp in this question, and that would also take n square time complexity as well as n space complexity. Now this is the best and the best approach, not the better, obviously the better approach if it's the best. First we need to deal with some things. If num is equal to null, or if nums dot length is less than 3, simply return false. Half of the test cases will be covered here. Now what we want to do is we want to create 2 variables. Let's call it minimum and minimum 2. So I'll call it min. I'll assign integer dot max underscore value to it. Again I'll make another variable, I'll call it min2, min2, and I'll just copy paste this here. Next what I want to do is I want to iterate through it, so it would be num dot length and I plus plus. Now I want to check for one condition. If my nums of I is less than my min 2. So what is min 1 is the smallest element present in this array, min 2 is the second smallest element present. Now we need to find a third element such that it is greater than min 2. If it is greater than min 2, I know that sounds like a nickname, but if it's greater than that variable, we for sure get a triplet, like one minimum second, minimum third, such that all of them are increasing. And since we are iterating only forwards, so k would be greater than j would be greater than I. Again, if it is greater than this, let's call it mid, it would be better, and I'll not mid, like okay, done. If it is greater than that, return true if we find any variable at any point of time. Else what can happen is that variable, the nums that we have right now, is greater than min, but it is also less than mid. Nums of I is less than mid. So what we want to do in this case is we want to change the value of mid. So we want to update mid to be equal to min. Done. Now what we want is check for what else can happen, else if it could be less than min. So let's check for that. If nums of I is actually less than min itself, then we need to update our min, make it equal to our nums of I. Now if this loops works fine, it should find a number, call it max, such that min, mid and max exist. But if it is not there, we can simply return false. If no such pair is found or number is found after this, we can simply return false. It's working here, and obviously it will work here. It does. So this was the easiest, most basic, simple thing. What you can also do is you have to make some changes if you don't want to use integer.max, or here you can use integer nums of 0 for both of them. But then this condition won't be the first condition, it would be after you find your min 1 and mid, then you could do it. It would take like also n complexity, but this is the easiest method to do it, and here it is. Thank you guys, and hope to see you again.